Most conversations about AI alignment still begin with control. How do we stop the system from doing the wrong thing? How do we restrict its outputs? How do we force it to obey the rules? Those are necessary questions, but they are not enough. Because control can prevent certain failures, but it does not automatically produce alignment. A system can be restricted and still be incoherent. It can be blocked from doing harm and still not understand what it is optimizing for. It can refuse certain actions and still drift over time. That is the problem with treating alignment as control. Control says, do not cross this line. But alignment has to ask a deeper question. What kind of system is this becoming? That question matters because advanced AI systems are not just static tools anymore. They increasingly operate across memory, tools, workflows, users, organizations, and long-running goals. In that kind of system, alignment cannot just be a set of external barriers. It has to be part of the architecture. A controlled system may be prevented from taking a dangerous action in one moment, but if the system has no stable memory, no feedback loop, no governance layer, no constraint structure, and no way to correct its own trajectory, then the deeper problem remains. It may still lose context. It may still repeat mistakes. It may still optimize for the wrong signal. It may still become useful in one narrow sense while becoming harmful in another. That is why alignment fails when it only uses control. Because control is reactive. It usually responds after a risk has been identified. But alignment has to be formative. It has to shape how the system interprets goals, handles uncertainty, responds to feedback, and remains coherent over time. This is especially important for recursive or agentic systems. A recursive system does not just produce an answer and stop. It may plan. It may act. It may observe the result. It may update its next step. It may call tools. It may interact with other systems. It may generate new context for itself. In that kind of loop, the alignment problem is not only about stopping bad outputs. It's about governing the loop itself. What does the system remember? What does it forget? What does it treat as feedback? What constraints are non-negotiable? What requires human approval? What values remain stable when the environment changes? Those are architectural questions, and they cannot be solved by control alone. Control without memory becomes brittle. Control without feedback becomes blind. Control without governance becomes arbitrary. Control without context becomes overcorrection. Control without purpose becomes containment. And containment is not the same thing as alignment. This does not mean control is useless. Control matters. Boundaries matter. Refusals matter. Permission systems matter. Safety layers matter. but they are only one part of a larger structure. If we want AI systems that remain useful, coherent, and accountable over time, then alignment has to move beyond the idea of simply forcing behavior from the outside. It has to become a relationship between intelligence, constraint, memory, feedback, and human purpose. That is where the deeper alignment question begins. Not, how do we force the system to obey? But, how do we build systems that can remain oriented toward human flourishing as they learn, adapt, and act? That is the difference between control-based alignment and something deeper. Control can stop a system, but alignment has to guide what the system is becoming. And if we miss that distinction, we may build systems that are technically constrained, but not truly aligned.